First off is going to be tangent. Tangent. So we had tangent when we studied trigonometry. The tangent ratio was the opposite over the adjacent side. We're doing the circles. We also have something. We also have a tangent. They are related. We can get into that later. But a tangent can be a line. It can be a segment. It can be a ray. I just put line here. It's a line in the plane of the circle that intersects the circle in exactly 1 point. Right? It intersects the circle in exactly 1 point. So here's our circle. Here's this line coming through. Boop, it hits at exactly 1 point right here. So we can call this a tangent line. And it is tangent at B. And we're going to learn some properties of tangent lines later on. Okay, so we're going to be doing some of these theorems again. Again, theorem 12-1. If a line is tangent to a circle, then the line is perpendicular. So if the line is tangent to a circle, remember tangent means it's going to intersect the circle exactly 1 time, right? Just 1 time. Then the line is perpendicular to the radius, drawn to the point of tangency. So in other words, if we have this tangent line, right here, we can say that it is going to be perpendicular to this radius. Right? So the tangent line and the radius are going to be forming 90 degrees. Okay? We can use that, so I forgot to write in here, but let's say we're trying to solve for x. And again, it's in the book it says here, so assume the lines are tangent. So assume the lines are tangent that look tangent. Assume the lines are tangent. So we've got this circle here, and you've got this line that comes out, DE, and it looks like it intersects just 1 time. So this is a tangent line. Or segment, I guess. Tangent segment. Okay, so what did we learn? We learned that if it's a tangent line, then it's going to be perpendicular to the radius here. So the tangent line and radius are going to be perpendicular, so that's going to be 90 degrees. So to solve for x, I can look at this and say, hey, this makes a triangle. So using the triangle angle sum theorem, I can say 90 plus x plus 38 equals 180. So let's add these up. 90 plus 30 is 120, so 128 plus x equals 180. Subtract 128 from both sides. So if you subtract 120, 180 minus 120, that's 60. Then subtract 8 more, so 60 minus 8. 60 minus 8 is 52. X is 52. All right, let's take a look here. So now again, it looks like we've got this ML. Looks like it touches once, so this is a tangent segment. And also right here, this is also tangent. Tangent. So to find this guy, we know that, okay, here's my radius, R. Here's another radius, so R. So the tangent and this radius are perpendicular, okay. The tangent here and this radius are also perpendicular here. Okay, so just like this one, except instead of using a triangle, it looks like I've got a quadrilateral. So to solve for x, I can say this plus this plus this plus this equals, remember a quadrilateral is like 2 different triangles inside, so 360. So I could say x plus 90 plus 117. I'll just put 90 again. 90 plus 90 plus 117 equals 180 degrees. So x plus 180 plus 117 equals, oh, you saw my mistake. Let's see if this works. Oh, cool. Equals 360. I'm sorry about that. It's 360 because it's a quadrilateral, not a triangle. So if we add these up, let's see, 100 plus 100. So x plus 100 plus 100 is 200. Let's add these up. 80 plus 10 is 90. So 80 plus 17 is 97. So 297 equals 360. Subtract 297 on both sides. That's like subtracting 300, that would be 60, and then adding 3 back, so 63. All right, so that's what we can do. Oops. Yeah, sorry, still getting the hang of this. Let's take a look at theorem 12-2. So if a line, the plane of a circle is perpendicular to a radius at its endpoint, then the line is tangent. So in other words, theorem 12-2 is just the converse to 12-1. Okay, this is just the converse. So 12-1 says if it's tangent, then it's perpendicular to the radius. Flip that around. It says if it's perpendicular radius, then the line is tangent. So just to make that clear, come over here. So it says, what can we conclude if OP is perpendicular to AB? I should add the little OP is perpendicular to line AB. Well, this OP, that's a radius, so that's good. If we have a radius perpendicular to this line out here, then we conclude, so then we can conclude AB, line AB, is a tangent line. So in other words, we know that this is going to touch the circle only one time. If this was like 91 degrees or 89 degrees, you could not say this is a tangent line. But because this is 90 degrees perpendicular, you can say this is tangent. So this is a problem that's very similar. Based on the information, is ML tangent? Okay, so here's ML. We're going to check ML, this guy right here. Is this guy tangent at point L? So the question is this tangent? Well, there's one way to check. If this was tangent, then here's our radius. Right? Here's our radius. So this line and the radius, if it was tangent, should make 90 degrees, right? So the question is, does this make 90 degrees here? And we learned a way to check if this makes 90 degrees. We can apply the Pythagorean theorem to check to see if a squared plus b squared equals c squared. If it does, then this is 90 degrees. And if this is 90 degrees, then we know it's a tangent line. So let's check. Let's check if a squared plus b squared equals c squared. If it is, then we know this is 90. So we can use either one of these for our a, so 7 squared plus b is 24 squared. Does that equal, question mark, let's put a question mark here, does that equal 25 squared? Well, 7 squared is 49. 24 squared, so let's just come down here, 24 times 24. 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9. 0 here, 2 times 4 is 8, 2 times 2 is 4, so 6 times 8 is 7. Carry that 1, so 576. question mark. Does that equal 25 squared? 25 times 25. Well, let's do it a different way here. 25 times 25. I'm going to draw this little box here. 25 times 25. What's the area here? 25 times 25. Well, I'm going to split that into something a little bit easier to decompose or easier to work with. 20 plus 5, that's the same thing as 25. And 20 plus 5. You don't have to do this. If you want to do the standard way, that's fine. All right, 25 times 25. So that would be 20 times 20, that's 400. 20 times 5 is 100. 20 times 5 is 100. And 5 times 5 is 25. So we kind of decompose 25 times 25. We get 400, 500, 600, right? 400, 500, 600, 25. And again, you don't have to do it this way. You can do it this way. I just wanted to show you that. All right, do these guys add up? Let's see. 576 plus 49. Come on now. 6 plus 9 is 15. 8 plus 4 is 12. Oh. So this is 625 equals 625. So yes. So since a squared plus b squared equals c squared, we know that this is a right angle. We know that this is perpendicular. Now, since this radius here is perpendicular to this line here, yes, we can say that this is tangent. Okay, so let's take a look at this theorem 12-3. So theorem 12-3, the two segments tangent to a circle from a point outside the circle are congruent. So if they're tangent to the circle from a point outside the circle, then they are going to be congruent. What do we mean by that? So here we've got a circle, circle O. We've got this point, point B. So this is outside the circle, like we just talked about, right? Outside the circle. If I have two segments, not just one, if I have two segments coming from this point, so here's one, there he is, he's tangent. And, let's say tangent. And here's another tangent. So it says if I've got two lines coming from a point outside, they're both tangent, then I can say that these two must be tick, tick, congruent. So what does that mean for us? So let's say I want to find, so I forgot to write this for these two guys, I want to find the perimeter. I want to find the perimeter. That would be all the way of the triangle, right? Of this triangle. Here, 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 triangle, what's this name? Sorry, A, B, C. Triangle A, B, C. Let's go ahead and find this perimeter. Well, you see we're missing some things here, but it's not so bad. I've got this point A outside the circle, and look, he's got this tangent line, AD, and this tangent line, AF. They're both tangent, and the problem it'll tell you, you can assume that they are tangent. So if they're both tangent, they're both coming from A, then I can say that this is going to this, and therefore this must be 10 centimeters as well. Coming here at point C, C is also outside the triangle. I've got a tangent line CF, or tangent segment, excuse me, and CE, so they're both tangent, touching at once. So I could again conclude, using theorem 12-3, that this tick tick is going to this tick tick. So this is 8 centimeters. And in a similar fashion, we've got point B out here. So we know that this part, this is tangent here, this is tangent here, they must be congruent. So this is going to be tick, 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 tick. You don't have to put the ticks, 15 centimeters. And now we can easily find the perimeter. So the part from the blue is going to be the perimeter equals 10 plus 10, which is 20, plus 8 plus 8, which is 16, plus 15 plus 15, which is 30. We add those up to get our final sum. So 20 plus 30 is 50, 66 centimeters. Okay, let's try one more here. So this one is kind of a little more interesting. We want to fill in all of these guys. We want to fill in every single one of these missing pieces. This time it tells you the perimeter of PQR is 88. So we already know the perimeter is 88 centimeters. Alright, so let's do what we did before. So P, well, I know that here's a tangent line P, or segment, excuse me, PX, and tangent segment PZ. They're both coming from this point P, so they're going to be congruent to each other. So this is going to be 15 centimeters. This is going to be RZ and RY are tangents, so this is going to be 17. But we're stuck now. We don't have that other piece. We used to have another number like this one. Well, what we can use is we know that if we add these all up, this plus this plus this plus this plus this plus this, it's going to equal 88. So why don't we just go ahead and call this X. And we know that since this is coming from Q, this is tangent, and this is also tangent. They're both coming from Q, so this is going to be congruent. They're going to be congruent to each other, so we got X and X. So the perimeter is, again, if we add these all up, we'd say, okay, we've got X plus X plus, what do we have here, 17 plus 17. 17 plus 17 is 34, plus 15 plus 15. 15 plus 15 is 30. So all these guys added up, that's going to give me the perimeter, which is 88. All right, so this plus this plus this plus this plus this plus this is 88, because that's given to us. Okay, then we just solve, so we get 2x plus 34 plus 30, 64, equals 88. We'll subtract 64 on both sides. So 2x equals 8 minus 4 is 4. 8 tens minus 6 tens is 2 tens. We divide both sides by 2, and we get x equals 12. And you can even plug that in right there to check to see if you're right. So 12 plus 12 is 24. 15 plus 15 is 30. So 30 plus 24, that's 54. 54 plus 17 times 2 is 34. So 54 plus 34, that's going to give you 88, which is exactly what we wanted. So yes, that works. Okay, let's take a look here then. Tangent lines. So let's recall that a tangent line touches the circle exactly once. Okay, just once. Now we also learned if it is a tangent line, then it forms 90 degrees with the radius, right? In other words, it is perpendicular. It is perpendicular with the radius. Okay? If it's a tangent, then it's 90 degrees with the radius. Likewise, we also learned the converse. If it forms 90 degrees with the radius, then it's a tangent line. So if it's a tangent, then it's 90 degrees with the radius. If it's 90 degrees with the radius, then it's a tangent line. Finally, two tangent lines that originate from the same point outside the circle, that's the key word, outside the circle, must be congruent. Okay, that was just a brief review of what we talked about. So let's go ahead and apply all of these. As we take a look at these, we'll do the even problems here. So number 2, find the angle measure indicated. Assume the lines which appear to be tangent are tangent. So let's find this guy. We'll call him X. All right. So first off, we've got this guy here. This appears to be tangent. It appears to be touching just once. See how it goes here? It touches just once. So since this is a tangent line, right? This is a tangent line. We know that this must make 90 degrees with this guy right here. And over here, this is another tangent line. So here's another radius. So this line must also make 90 degrees. Right? Got a tangent line here, touches once. Tangent line here, touches once, just once. So it makes 90 degrees with this radius. So if you look carefully, you see that we have here a quadrilateral. So a quadrilateral, the inside angles are going to add up to 360. So this plus this plus this plus this, x plus 90 plus 90 plus 135 is going to equal 360. All right, so we get, this is 180. Uh, 180 plus 135, so it's going to be 200. 80 plus 30 is 110, so 310, 315. And we'll go ahead and subtract out 315. That's going to be 0 pair, so x equals 60 minus 10 is 50, minus 5 is 45. So this is 45 degrees. Let's come down here. All right, this one's a little bit more of a challenge. Okay, so number 4, I've got this guy right here. This guy, we'll call him x. We want this angle right here. Okay, this is kind of tricky. So what you see here, it looks like we've got a triangle this time. This big triangle here. I've got a tangent line. See here, this is not a tangent line because he touches it 1, 2 times, right? 1, 2. That's not tangent. But this is a tangent line. This is a tangent line because look, he's only touching the circle 1 time. 1 time. So we know the tangent line, here's a radius, makes 90 degrees. So we think, okay, let's look at this triangle first. Okay, that makes 180. Notice that this x is not part of this big blue triangle I drew. So we need to do a little bit of work afterwards. But first off, let's see if we can find, we'll call this guy y right here. What would angle y be? Well, this one's a little bit easier. We can just say 56 plus y plus 90 is going to equal 180 because that's a triangle. All right, 56 plus y plus 90 equals 180. All right, this plus this plus this. Ignore x for now. Let's add up 56 and 90. 90 plus 56 is 146. Okay, we subtract 146 from both sides. And we get y equals 80 minus 40 is 40. 40 minus 6 more is 34. Okay, so y is 34. So this is 34. Let me erase that and put 34. Okay, 34. Now, what do we do now? This one's pretty tricky. Let me give you a hint here. Here's the center, right? Here's the center. This line right here comes all the way from the center out. So that is a radius. All right, coming out here as well. This is another radius. And look, I can make another triangle here. So if you've got a triangle with radius, radius, these have to be the same. We don't know how long the radius is. We can put it ticked here. Oh, what type of triangle do we have here? That's right, we have an isosceles triangle. I heard you answer that correctly. That's right, good. So, you can put arc if you want. So 34. So if this is 34, x is going to be, if you look carefully, this makes a straight angle, straight line. So x plus 34 must equal a straight angle, or 180. So x plus 34 equals 180, right? This plus this. Just subtract 34 for both sides. we get x equals, well, 80, 100. 80 minus 30 is 50. 50 minus 4 is 46. So x equals 146 degrees. All right, so next off here says determine if AB is tangent to the circle. Determine if AB is tangent to the circle. So remember what we talked about. We said if something is tangent, then it's going to form 90 degrees with the radius. Okay, so if it forms 90 degrees with the radius, it'll form this right triangle, right? If it forms 90 degrees with the radius. So let's check here. If this is tangent, let's check. If this is tangent, let's put a question mark here. Then this should be, well, let's see here. Tangent, let's put tangent, question mark. Is this a tangent line? Is this only touching one time? If this is a tangent line, then this should be 90 degrees. Well, there's a quick and easy way to check if something is 90 degrees. That's to check, does the Pythagorean theorem hold? Right? Does the Pythagorean theorem hold? In other words, does a squared plus b squared equal c squared? Does it? If it does, then this is good to go. So let's try it. So a squared, that would be either 8 or 6. We'll do 6. So 6 squared plus 8 squared equal the hypotenuse across from this right angle, we think, 10 squared. 6 squared plus 8 squared, does that equal 10 squared? Well, that's 36. 8 times 8, 64. Question mark, I should put a question mark here. 10 squared is 100. And we add up 36 plus 64. 30 plus 60 is 90. 6 plus 4 is 10. 90 plus 10 is 100. So, if a squared plus b squared does equal c squared, yes, we know that this is a right angle. Yes. And if this is a right angle, we know that this is a tangent line. Yes. So we can say, yes, this is tangent. Okay? Let's go ahead and take a look at, I said I'd be doing the evens, but this one's kind of interesting as well, so I want to take a look here together. So again, is it tangent? Is this line, is this line here tangent? Is it tangent? Question mark. Well, if it is tangent, then this guy and the radius should form 90 degrees. So if it's tangent, is it tangent? Is this 90 degrees? If we answer this, then we can check. So again, we can ask ourselves, does a squared plus b squared equal c squared? Question mark. A squared plus b squared equals c squared. Well, here's the thing. I've got a 9 here. Got a 9 here. I'm missing this piece. I'm missing this piece right here. Think very carefully what you know about circle and a radius. So look at this. Look at this right here. See how that's 3? But it doesn't mean just this is 3. That means any radius is going to be 3. This is 3. This is 3. And that means that this piece also is going to be 3. So don't forget about the radius when you're doing these problems. So if that's 3, then this is 3, etc., etc., etc. So now we can find what to check for here. So we got our a squared. We'll do this. We can do the 3, but we'll do 9. 9 squared plus, we know this is 3 because it's the same as this, the radius, 3 squared. Does that equal, now what is this whole hypotenuse going to be? It's going to be this piece and this piece combined. We're going to not add, we're not going to subtract, we're going to add them up. So 7.2 plus 3 is going to be 10.2. And let's go ahead and put that in parentheses. Okay. So 9 squared, 9 times 9, 81. 3 squared is 9. Pretty sure this is not going to work, but let's check. 10.2 times 10.2. We'll just do it like this. Okay, so we will multiply 2 times 2, 4. 2 times 0 is 0. 2 times 1 is 2. Okay, add the 0 here. 0 times 2 is 0. 0 times 0 is 0. 0 times 1 is 0. And finally, add 2 zeros, excuse me, for this place. 1 times 2 is, 2. 1 times 0 is 0. 1 times 1 is 1. So 4, 0. 2 plus 2 is 4, 0, 1. And we move the decimal 1, 2 places. 1, 1, 2. So right there. So we get 104.04. 104.04. So we can see clearly that these guys are not equal. 81 plus 9 is 90. So if that's not true, that doesn't hold, then this is not a right angle. This is not a right angle. If a squared plus b squared is not equal to c squared. If this is not a right angle, then we know it is not a tangent. So we can say no, not tangent. Okay, so I'll let you guys do number 8 on your own. I know I said you will do the evens, but I lied. So you're going to do that even problem. Rather, let's go ahead and try these next group of problems here. It says, find the perimeter of each polygon. Assume the lines which are tangent, appear to be tangent are indeed tangent. So I lied. We'll do the odds. So we're switching up. Find the perimeter. Find the perimeter. So remember, the perimeter is just, again, going to be all the area on the outside. This plus this plus this. So you back those up. So we already practiced this once, but we know that, okay, let me do this in red. This is a tangent line because he touches just one time. This is also a tangent line because he touches just one time. They both come from the same point, so they are going to be congruent. So this is 8.3, this is 8.3. Okay, same thing over here. This guy comes from out here. This is 8.2. This is going to be 8.2. And finally, if this guy right here, this is going to be, we don't have either one. Well, but we do know that the whole thing is 17.3. The whole thing is 17.3. This piece is 8.3, so let's just subtract this piece. So 17.3 minus 8.3, and that'll give us this pink part right here. So 0.3, that just becomes 0, and we're going to get 7 minus 8. We're going to borrow here, so 0, 10s. 17 ones minus 8 ones, that's going to give us 9. So this is going to be 9 here. And you can check that. 9 plus 8.3 does indeed give you 17.3. So if this is 9, because they're both tangent from the same point, this is 9. And then we can just add them all up to get our total perimeter. So the perimeter equals this 9 plus 9. So 9 plus 9, or you can do 9 times 2 if you want, plus 8.2 plus 8.2, or 8.2 times 2. Sorry, back up. Plus 8.3 plus 8.3. It's probably better just to multiply by 2. Okay, let's see here. So 9 plus 9 obviously is 18. This is going to be 16.4. Right, 16.4. And this is going to be 16.6. Add them all up, and we're going to get, let's see. Why don't we add up the whole numbers first? So 18 plus 16 plus 16. Well, 16 plus 16 is 32. 32 plus 18. Well, let's break this into 10 and 8. So 32 plus 10 is 42. 42 plus 8 more. 42 plus 8 more, that's 50. Okay, so that's 50 plus 0.4 plus 0.6. What's 0.4 plus 0.6? Well, that's just 1. So 50 plus 1 more gives us 51. The perimeter is 51. try one more here. We're going to find the perimeter. So again, we know that anything coming from this guy and this guy, they're both tangent lines from the same point on the outside, so they must be congruent. You put a tick-tick if you want. 7.8 and 7.8. 7.8 and 7.8, which means this guy and this guy are also congruent. This guy and this guy. Well, if the whole thing is 17.8 and this is 7.8, what is 17.8 minus 7.8? That's just 10, right? That's just 10. You can add 10 plus 7.8, 17.8. Since they're both tangent lines, this is also 10. And we just need to do a little bit of work to figure out this one. What are these two guys going to be? Well, if this whole thing is 16.9 and this is 7.8, we just need to subtract out the pink part. So 16.9, I'll do that black. 16.9. We'll subtract out the pink part, minus 7.8, and that'll give us our green guy here. So 0.9 minus 0.8 is 0.1. 6 minus 7, we have to borrow here. 16 minus 7, 9, so 9.1. And you can double check that. 9 plus 7 is 16. 0.8 plus 0.1 is 0.9. You add them together, you get the same thing. All right, so our total perimeter is going to be all of these added up. So the perimeter equals, let's just double these. 10 times 2 is 20. Let's double this. So 7 times 7 is 14. 7 times 2 is 14. 0.8 plus 0.8 is 1.6. So 14. 7 plus 7, 14. 0.8 plus 0.8. So 14 plus 1.6. 14 plus 1.6. That's 15.6. And finally, 9 plus 9 is 18. 0.1 plus 0.1 is 0.2. 18.2. All right, so we're going to get, let's add up all the whole numbers. 20, 15, so 20 plus 15 is 35. 35 plus 18, just pretend that's a 20 for now. 35 plus 20 is 45. Take away 2 more, that's 43. 43.6 plus 0.2, that's 0.8. 43.8. So the perimeter is 43.8. All right, coming down here, finally, it says to find the segment length indicated. Find the segment length indicated, that's right here. Assume the lines that are tangent are indeed tangent. So assume the lines that are tangent are indeed tangent. So we can assume, where's our tangent line? This is not tangent because look, he's hitting it 1, 2 places. That's not tangent. But look here, he's only hitting it 1. So this is a tangent line. It says we can assume that. It's not a question mark. We know that this is tangent. So if this is tangent, what do we know about the tangent and the radius? What do we know? We know that they make 90 degrees. So if they make 90 degrees, how can we find, first, don't worry about this little x right now. Let's look at this triangle here. How can we find this whole missing side? We'll call this guy, I don't know, call this guy y. Well, we'll just use the Pythagorean theorem. We'll say, all right, we'll use a squared plus b squared equals c squared. We know this is true because we can assume it's tangent. We're not checking, we know it's tangent. So we know a squared, that's 8, plus b squared, the whole thing is y, not x, equals c squared, and that tells us it's 17. Okay, let's go ahead and do this. So 8 times 8 is 64, plus y squared equals 17 times 17. 17 times 17, 7 times 7 is 49. 1 times 7 is 7, 7 plus 4 is 11. 1 times 7 is 7, 1 times 1 is 1. So 9, 8, 289. Okay, so we get y by itself here. We're going to subtract 64 from both sides. 9 minus 4 is 5. 8 minus 8 tens minus 6 tens is 2 tens. Okay, so y squared is 225. So why don't we square root both sides, and the square root of 225 is 15. So this whole thing is 15. Whole thing is 15. But remember, we don't want this whole thing here. We want just x. We want just x. So that would simply be, since the radius is half of this, it would just be 15. So x equals 15 divided by 2. And since 2 goes into 15 7 times, right? 7 times 2 is 14 with 1 half left over. You can write 15 over 2, you can write 7.5, or you can write 7.5. Any one of these is fine.